This tutorial will be a helpful guide for the user to understand the input Excel file so as to run successful simulation of ChemPlace software. This Excel file is a standard input file format to be used in model building in ChemPlace. You need to download this standard input Excel file from our software and then update the data from this Excel file according to your well, reservoir, and fluid properties. You then need to upload it in our software to build your well model and run simulation. The overall structure of this Excel file is that it has a total of 10 tables. These include the reservoir lithology table, the injection plan, the well data, injection data, fluid properties, well completion, Dts data, sensitivity data, wormhole profile, and co-flood data. Since this is a carbonate acidizing module, this input file will have a co-flood data table. Other modules may have different tables. It is very important to remember that you don't need to edit the names of tables or columns or fill any column which does not have any data need. You only have to edit data in these 10 tables. The software uses field units in its calculations. However, to be clear, please take care of input parameters units as mentioned on top of each column for every input data. If in case the user does not have any data available, then you can skip that cell as default value. This is the reservoir lithology table. User has to provide the reservoir layer properties in this table. User can subdivide a single reservoir layer into multiple small sublayers to calculate fluid placement per foot. User has to update the reservoir layer properties in this layer. These properties include the measured depth, the true vertical depth, the permeability, porosity, the zonal pressure, peak stimulation skin, and reservoir fluid type for each reservoir layer. This is the injection plan table. The stages here define the different stages that occur during well stimulation operation, such as pre-flush, acid injection, diverter injection, and overflush stage. User will enter the start time and the end time for each stages, as well as define properties such as fluid volume, concentration, viscosity, pump rate, and pumping pressure. The bottom hole pressure, injection depth, and frictional pressure are optional. This is the well data table. Here, the user will provide the well properties necessary for successful simulation of the software. User will also provide the perforation parameters for wells with cased and perforated completions. The well data properties may depend on if the well is vertical, slanted, or horizontal. This is the injection data table. Here, the user will enter values depending on if the injection method being used is bullheading or coil tubing, the rock properties, and the skin created due to formation damage. The next table is the fluid properties table. In this table, user will provide values for the reservoir fluid properties in the formation, the fluid flow type, and the phase type. User will also provide values for the properties of acid being injected for the stimulation job. If the user has selected the type of completion method as cased and perforated completion, user will have to enter values in the well completion table by mentioning the perforation height for each layer. If the user has selected the type of completion method as open hole completion, user does not need to clear the cells in the table and let the default values be present. The next table is the Dts data. User can enter the distributed temperature sensing data for history matching of the wellbore model. However, this table is optional and user can leave the default values as it is if they do not have the data. The sensitivity data table allows the user sensitivity analysis of parameters such as viscosity, pump rate, acid concentration, and acid volume, and evaluate their impact on the stimulation job design. This can be done by running 3 cases from each parameter and comparing the results of the acid placement, acid penetration length, post-stimulation skin, and productivity index. The next 2 tables are meant only for the carbonate acidizing module. The wormhole profile allows user to enter the laboratory results of the co-flood test. User will enter the values of the pore volume to break through with respect to the interstitial velocity. If the user has not conducted the co-flood test, they can provide the co-flood data in the next table. Based on the user's data, the software will measure the wormhole profile of the reservoir formation. User can also access the user manual from the website for a more detailed explanation of the input Excel file. Thank you.